So hi guys, my name is Yashwardhan Chaudhuri, and I'll be talking about Project Seshu. We have now named it FEDM. I'll explain you why we have named it FEDM. So earlier we started this project as an engineering project, right? We thought that we'll use some stuff from online and then we'll build a wrapper and do something different. But it turned into a research project, and I am very excited to show you some of our stuff. So let me ask you something right now. People are building really cool stuff with LLMs, right? People are fine tuning it, building wrappers, doing some crazy stuff, and solving some real life problems. Am I right? I'm just trying to keep it interactive. So please feel free to get into the like have a conversation. So yeah, please. Like we all know that LLMs are the hype right now, and people are doing a lot of stuff with it. But let me ask you a very fundamental question: that we are essentially fine tuning these models. We can't pre-train them with the existing compute that a person has. We have got Mistral models, we have got Llama, we have got such some really big models, but a single entity like me, you, or any other college student cannot do this because of the compute issues. So we are trying to solve this problem. And let's say right now we have got some models that have 150 billion parameters and might go even up. But what will happen when the society needs a 1 trillion parameter model? So then problems will start to rise. And let's say that we somehow make that model by collaborating, etc. What will happen after that? How will you handle the model drifts? Will you continuously train a 1 trillion parameter model? I don't think so. So with that problem, we started our project Seshu, which is now FEDM. FEDM is the like short form for federated emergence. And I guess people can now think about what we are trying to do. We are effectively decentralizing the LLM pre-training process completely. So by this process, we are effectively making the LLM pre-training transparent, responsible, and equitable. So let me show you some papers. So the impact of open foundational models. Like this is one of the very famous papers from Stanford, and they have stated that it accelerates science, it enables transparency, increases innovation. Let me show you another paper. So this paper was published in ACM 2023, and they talk about making LLMs open source software. I wonder how. Okay, they are saying that we can build an open source software. We can build LLMs like open source softwares. Let's move another question. So we have one more thing, Byte T5. Uh, I cannot see people out there, but can somebody raise their hand if they have heard of Byte T5 before? Is somebody raising their hand?
No, not anyone there.
Yeah. Okay. Okay. So Byte T5 is a really cool thing. So right now, all the LLMs, what they use is we have got a tokenizer, we have got an LLM, we sort of merge it. The tokenizer does its stuff, creates tokens, and LLM does the processing, right? Now, will you train tokenizer for 840 languages? Like there are approximately 840 languages in India. It's really difficult. So in this time, Byte5 kind of solutions work very well. These type of LLMs, these type of language models work directly on raw UTF-8 characters. And it has shown some really competitive performance. So again, Mamba. How many of you have heard about Mamba? This is a really famous paper right now and everybody is getting into it. Anybody?
Yeah, quite a few.
Yeah, yes. Nice. So, so Mamba is a state space model, and the good thing about it is that it uses a linearly shaped attention. Linearly, so we know that LLMs use a quadratic attention, right? So Mamba uses a linear time attention, and it makes it really fast. So now think about a model that merges this raw UTF-8 character thing and this Mamba together. What do we get? we get something like Mamba byte. And this paper was published, is a very recent paper, and it's from Cornell, right? So like this model gives a
Yes, just a quick time check. It's already 5 minutes. Okay.
Oh, damn. Okay.
You have 5 more minutes.
Okay. So I'll just fast forward it. I got into the flow. So what we are trying to do is we are sort of decentralizing the LLM training altogether. And we are building something that is completely transparent, completely equitable. All the data is transparent. Anybody can get in. Anybody can contribute to the training of a very large language model. We are talking somewhere around a 1 trillion parameter model. So let's get into it. So with this thing in our mind, we developed FedM. FedM is a twofold thing. So first, it's a get-like system. You can pull a pre-trained model, take some data that we have curated ourselves using 11 different languages from Bharat AI. Bharat AI, AI for Bharat. And we use that data, do a low-cost update on one particular layer in a large language model, and we change the architecture and then push it back to the hub. And for this, this is something that makes everything open sourced. Anybody can come in, you, me, anybody, and start contributing and adding to the knowledge framework of such large language models. And we are currently using a Mamba byte kind of architecture, but for the context of what do you say? For Indian context. And for that, we have curated our own data set using the 11 languages of Bharat, AI for Bharat, right? So again, just fast forwarding it because I've been lacking time. So we have got two things, client and server. This is completely our own innovation kind of thing. So we have a library called FedM. You do pip install FedM. It's available on PyPy. All the documentation, etc. is there. You can check it out. You make a Seshu object and you access the LoRa adapter from there. Let's say you want to update model 3. And once you do that, the client gets the adapter. You apply some low rank adaptation. You fine tune that low rank adaptation, and then it's get transferred back to the hub. You sort of merge it with the pre-trained Mamba, and now you have got a new model that has a different distribution inside it, distribution of data. So you are continuously wrapping it up. You are continuously changing it with the data drifts. You are continuously adapting it to the new language semantics, etc. Now, now there are some few people who are doing it, but let me tell you one thing, it's incredibly complex. You might leave the task before getting started with it. So FedM is quite simple. You just need 3 lines of code to do this. I'll show you in a bit. So for this, we developed something called as continuous relay fine tuning. Continuous relay fine tuning so think of it in a relay manner. Person A comes, person A downloads the low rank adapter, fine tunes it on one's end, then pushes it to hub. The same low rank the adapter gets taken by person B. It again gets fine tuned and gets sent. It's a relay like fashion that continuously changes the internal distribution of numbers, so as to speak, and continually to adapt to new data. So this was our roadmap. We built a Mamba compatible transformer class. It's available on the GitHub profile. We built the LoRa, etc., etc. All the stuff is done. We developed the client-side code. We modified the Samantha dataset that is from AI for Bharat, and then we completed the pipeline. So basically, you can get on right now and start training if you want. So I'll show you the stuff. Just a second. Okay, so let's first see our repo. So this is our repo. You can read about our continuous relay fine tuning, etc., and how we are selectively locking the adapters, etc., etc. It's cool. So that's one thing. Now let's look at FedM. So in the interest of time, I'll just show you one of the pipelines. So this is for the client side. That means what you and me can do. We install FedM. We log in on Hugging Face. So currently we have got something called as ML Square, our Hugging Face page. You sort of become a contributor here, and then you can start pre-training or fine-tuning on your end. You log in with this API, the right API. You simply just import Seshu from the client side, write one cell, and then you can start doing LoRa adaptation. It's that simple. And you can sort of contribute to a very large model like this. So our approaches is not just something that is out of the blue arbitrarily. We have seen some really good stuff. So Mamba Byte thing, this type of model has shown a 2.6 times inference speed up from the existing Mamba implementations. Then are thinking of making low rank adaptation. This is a rather popular paper from Tanmay Chakrabarti. He's a professor in IIT Delhi. He talks about chain of thought essentially, and how different layers handle different kind of information. So when you're training one kind of layer in this large language model using our FedM, you are essentially training the distribution in that area. So cumulatively, when thousands and thousands of people compile this together, you build a new large language model that is completely, it's again and again adapting to as new data comes in. Then this is the paper from Mamba. You can check it out. This is added in the ML Square repository. And yeah, that's it. This is the, what do you say? The PyPy page, pip install pattern. And yes, that's pretty much it from my side. If you want more data, yeah, let's talk about future plans. So currently this is 0.0.7 of its true form. This is, we started as a hackathon project, but I don't think we are going to limit ourselves to this point. We have planned some really crazy stuff in future. So we are going to try different merging technology, merging techniques. We are going to try different kind of adapter formulations, etc., etc. You must have heard that now we have got Dora, we have got a different kind of Dara, something like that. And so we are going to make a library that has support for all of these. And the thing is that our library can be integrated with any kind of large language model. So people have proposed their fine-tuning models. I invite them. Maybe they can use our framework and start doing a distributed training for large language models. So yeah, that's pretty much it from my end. I'm open to questions if you have any.
Yeah, my question was, in this distributed way of training, how do we ensure some kind of governance? Like one person training might bias the model in one direction. How would we control for that?
That is a very good question, ma'am, and we did think about this. So the data we have right now is called Samananta dataset. It has got support for 11 Indian languages such as Assamese, Gujarati, etc., etc. And for any one person, we are not biasing it because we are only taking a certain set of data. At any point of time, the person is randomly taking only 50% of the data for training. The data is sent by us. The person just fine tunes the adapter on their end, nothing else.
No, I think the question is, how do you see? I mean, let's say as a community, you're building a network, right? Imagine one layer is being trained by one particular person. How do you ensure that that person is not biasing it in a very different direction than the rest of the people?
As in, yeah.
Yeah, I mean, you said that the data is also sent by you. This is only the compute that is getting utilized, right?
Exactly.
So, but I mean, there again, you can always have breach of the data, right? Huh? Like
So,
I think that.
yes, ma'am, definitely. So in that case, sorry, I couldn't hear what.
Adversarial attacks, meaning instead of your data, they're giving you something else, right?
So we did think about all this stuff. We have a very premature solution for this. I don't think it will work out in the longer run. We were thinking of taking the SOPs of people who want to contribute. So maybe what is the reason they are doing and what kind of compute they are going to give. And then probably they can start training. So you have to first become the contributor at Hugging Face page and then it can start. But yes, your question is completely valid, ma'am.
Okay.
You do need to think.
Other questions?
Yeah.
Sorry, go ahead, Tanuja.
Is this primarily focusing only on making the larger compute available for training large models when the all the data is available with, let's say, one centralized entity?
Yes, ma'am. The data is going to be open sourced. So for example, AI for Bharat has got some really good data sets. We are going to use that. And yes, as a person, you and me, we only ask for the compute. That is the whole purpose of this library, to sort of ask for compute. And no one person has the complete dominance in the market for making these large language models.
So primarily one suggestion here, right?
Yes.
If you go back to the original federated learning models, right? One advantage of federated learning model is you don't have to kind of send data back centrally, right? And you can utilize distributed data. If you have certain proprietary data or let's say interesting data, and I have some interesting data, both of us can train from the base model and send our learnings back without compromising on the data, right?
Okay.
If there is appropriate governance in place to make sure that the model is learning and not deviating from the, let's say, base checkpoint, there could be interesting ways in which people can contribute not only just compute, but from their proprietary data, which they would not be interested in sharing, let's say, in the open domain, but there is a value in that data.
Okay, ma'am. So what I understood from what you're saying is that we can probably set a governance kind of thing, that how people are contributing, right? So
yeah, some rules to make sure that your model is learning and not kind of degrading, right, with the every new iteration which is happening from the LoRa adaptation. But at the same time, it's not happening only on the centralized data, which is like one chunk, and because data is another problem, right? Isn't for training any of these models, getting the appropriate data, and many a times this data would be proprietary. People are not interested in putting it out. Can you learn more by utilizing proprietary data without really putting it out?
yes, ma'am. Definitely, it is something that we can think about in future. And so I'll be very honest with you. We did, as a team, we did start thinking like, okay, it's a hackathon project, maybe in the first week, but we have got really attached to this problem, and probably we'll keep building it. And in fact, I asked the people out there to maybe ask us to maybe join in. We would love to have you all here, and ideas like this actually like the project. Definitely, ma'am, we can think about it. So as an initial starting, so I'll tell you one thing. Can you look at this diagram? Is it visible?
Yeah.
Okay. So we have a client and we have got a server, right? So the server side will be handled by someone, but it will be just 2 or 3 people, no more. So what they do is, let me show you the code. They might set up backend. So we say that we organize the architecture, maybe say 130 million parameter model, and then you can maybe start the pre-training. That is
Yes,
something.
sorry. Can we take the details offline? We have to finish 3 more and we are already late by an hour.
How
Sorry.
about 1 minute?
Yes, sounds good.
Yeah. So the evaluation, etc., can be handled on the server side, and there will be someone who can govern this stuff. So we did think about all these things, but the major contribution was that a person like me and you can start training on the laptop, and you together make something really open source that is actually open source. There is no model as such that, like, there is no monopoly, there is absolutely nothing, just pure compute and contribution, nothing else. So yes, ma'am. I think I have taken a lot of time.
So
Yes.
just a final question, maybe just to help me understand, like, the Membabyte is already a paper from Soma, right? Probably they already have a source code available and which you have borrowed from. Apart from this, building this whole library, right? How difficult it would have been, because it more looks like, you download the model, you pre-train it with the new data, and then you upload the model and the checkpoint. So what is the complexity of the solution that you have built?
Honestly, ma'am, maybe the solution sounds simple because I told it like that, but trust me, it was really difficult. So there is problems like sequencing, the how you are sequencing the adapters, how the data distribution inside is changing, how we are sort of making the code reproducible, the extent. So I'll show you something. Our library has passed multiple test cases. And these test cases ensure that the models and everything inside is reproducible. It's not limited to just our hackathon. It's something that can go on for maybe years to come. So that's pretty much the sophistication as well as the idea of distributed training using continuous relay fine tuning was a major contribution from our end.
Nice, interesting project for sure. Thanks.